This is an extra problem for 12.3, polar area problem. It's example 6 out of the textbook, at least the edition I'm using. So they say, okay, we have two curves, 3 cosine theta and 1 plus cosine theta. So 3 cosine theta is a circle, 1 plus cosine theta is the cardioid. And they say find area of those 3 regions. All right, above the x-axis. So we'll have to figure out how to set up these integrals, and I think this point of intersection might be important. So how do we find that? We'll set them equal to each other. One is equal to 2 cosine theta, or 1/2 is equal to cosine theta. Better now. Anyways, that has a solution at pi over 3. There are other solutions. I don't think any others will matter for what we're trying to find here above the x-axis, but I think that one solution is what we'll need. So let's look at region A first. And remember, we're trying to find the area inside a polar curve. It was 1/2 times the radius, or the function of theta squared, d theta, from whatever starting angle to whatever ending angle. That was where we had some situation like this. And still messed up. From changing the tablet settings, hopefully it works now. That was for getting some area inside a single curve. Not sure we've done one of these yet, but if there are 2 curves, area between them, it was, or you can use something like this. An outer radius minus an inner radius, similar to the area between curve stuff, but now it's squared. All right, so we'll probably need to use that for A, for region A. So let's look at region A. I'm going to draw those arrows on there. I might erase them for the next region, so they'll get in the way. But we are going from, it looks like 0 all the way over to the intersection point, and we're getting that area in between the blue and the red curve. So I think let's go from 0 to pi over 3. And then this is a case where we need kind of the area between the 2 polar curves, so we'll use the outer radius minus the inner radius, so 1/2. Outer is the circle, so 3 cosine theta. There is the cardioid. data, and we'll get some cosine squared terms in there. So we'll have to use our double angle identity or power reducing identity. Cosine squared is 1 plus cosine of 2 theta all over 2. But I just wanted to set these up, not go all the way through. Evaluation. So I think that takes care of A. That was maybe the quickest one. Let me do B in red. So for B, okay, I'm drawing my thin wedges. And we can see it's not the area, these wedges wouldn't be the area between two curves now, they're just the area inside a curve, but we transition at some, or at that intersection point from one to the other. So let's set that up. So for the first part, we're on the cardioid, so 1 plus cosine theta. That goes until the intersection point, and then we can see these arrows after that are hitting the circle. All right, so we need to get all the areas, so we have to hit the circle now, and start at pi over 3, 1/2, circle squared. Now, what is the upper limit? That would correspond to when the circle gets back to the origin. So we're swinging around. Hopefully you can see my cursor, and then we hit the origin. I think that's at pi over 2. So if I plug in pi over 2 to cosine theta, I get 0. So 0 radius, that makes sense. All right, let's look at C. And just to emphasize the dividing line on region B, that dotted line. All right, I'm going to erase all that because we'll need some space for the C picture. Space at least. Let me zoom in. So for C, that shaded area, so it's between two curves from pi over 3 to pi over 2. Really draw well on this one. But what happens after pi over 2? I need to get this part on the left from the cardioid. There, the arrows are just going out to the cardioid. It's not between the circle and the cardioid. So there's 2 parts, and I think that second part would end at pi. If I do 1 plus cosine pi, that gets me 0 for the radius, so that is that point at the origin. So let's set that up. Pen. First part would be between 2 curves. That was the part on the right, so it's 1/2. Order is the cardioid. Inner circle. That takes care of the right part. On the left, it's not between the curves, it's just going out to the cardioid, so pi over 2, and I think we said all the way out, swings all the way around to pi. And again, we get a bunch of cosine squared theta terms. You'd have to use the identity, but we are done that a bunch, so you should be used to it by now. So memorizing formulas isn't going to get you through these harder problems. That is, hopefully I've emphasized that enough in the previous examples. But this was a good chance to draw some pictures and see how these things work, so I hope you liked it. If you want to look at the book's pictures, it's example 6. 3. But that's it for the video.